Hi, in this video, we are going to discuss about how to convert a binary to gray code as well as gray code to binary. First, we will discuss about what is gray code. So, gray code is an arrangement of binary number system such that each incremental value can only differ by 1 bit. That is a definition for gray code. So, gray code is an arrangement of binary number system such that each incremental value can only differ by 1 bit. So the other name for gray code is reflected binary code, cyclic code, reflected binary. The reason for calling this code as reflected binary code is the first n by 2 values compared with those of last n by 2 values in reverse order. So in gray code, when traverse from one step to another step, the only one bit will be change of the group. This means that two adjacent code numbers differ from each other by only 1 bit. It is popular for unit distance code, but it is not used from arithmetic operations. This code has some application like convert analog to digital, error correction in digital communication. These are the steps for binary to gray code conversion. So the step number 1 is the most significant bit of the gray code is equal to the first bit of the given binary bit. The most significant bit of the gray code is equal to the first bit of the given binary bit. The second bit of the gray code will be the exclusive OR of the first and second bit of the given binary bit. Again, the third bit of the gray code is equal to the exclusive OR of the second and third binary bits. For further gray code result, this process will be continuing. So we will see one example. So this is a given binary digit. So what is a given binary digit is 0, 1, 0, 0, 1. And here this is a LSB, that is least significant bit, and this is a MSB, that is the most significant bit. As per our rule, the MSB, that is the most significant bit of the gray code, is equal to the first bit of the given binary bit. So this will be same. So 0, whatever bit is there, that will be retained. 0 means 0 and 1 means 1. And second bit, the second bit of the gray code will be the exclusive OR of first and second bit of the given binary bit. So this is the first bit and this is the second bit. So the second bit is an exclusive OR of first bit and second bit, 0 XOR 1. And this is a XOR table. What is XOR with exclusive OR? This is a truth table for exclusive OR. So the truth table of exclusive OR is whenever both bits are same, the result is 0. Okay, so here 0, 0 means 0, 1, 1 means also 0. If any one of the bit differs, that is 0, 1, 1, 0 means the result is 1. So now the exclusive OR of 0 and 1 is 1. And for the next bit, we have to take second and third bit, 1 XOR 0. So 1 XOR 0 is again 1. The next bit is 0 XOR 0. So 0 XOR 0. So 0 XOR 0 is again a 0. Then next bit is 0 XOR 1. So what is 0 XOR 1 is? 0 XOR 1 is 1. Now what is the gray code? Corresponding gray code for the given binary code is 0, 1, 1, 0, 1. This is a binary to gray code. So now we will see next example. The gray code of the given binary code is what is a gray code of the given binary code? 010.01. Okay, here again take the first bit. What is the first bit is 0. So take the first bit. So the first bit of the given binary is same as that of this one 0. So the first MSB bit of the binary is same in the first bit of the gray code in this example. So it is 0. So the gray bit is also 0. The next gray bit is equal to the XOR of first and second. Okay, XOR of first and second. So these two we have to take the XOR, 0 XOR 1. So 0 XOR 1 is 1. So the bits are different. So resultant gray bit will be 1. Next bit, the XOR of second and third bit, 1 XOR 0. The XOR of the second and third binary bit. So the second bit is 0 and third bit is, sorry, second bit is 1 and third bit is 0. So answer is again 1. The resultant gray bit will be 1. Next we perform the XOR operation of the third and fourth binary bit. So third bit is 0 and fourth bit is also 0. So 0 XOR 0 is 0. Both the bits are same, then the resultant gray codes will be 0. So it is answer is 0. And finally fourth and fifth bit, 0 and 1. So 0 and 1, the XOR of 0 and 1 is 1. So what is our result? Result is first bit is 0. First bit is 0. Then next one is 0 XOR 1 is 1. Next again 1 XOR 0 is again 1 point. 0 XOR 0 is 0 and 0 XOR 1 is 1. So answer is 011.01. That will be the answer for this particular example. Now this is a gate diagram for the binary to gray code converter. Okay, so first bit, so that is G4 will be remains the same, and G3 will be XOR of first bit and second bit. This is a XOR, this is the first bit and this is the second bit. So XOR of first and second bit will be G3, and G2 will be XOR of second and third bit. So second and third bit is this one, B XOR C, that will be G2, and G1 again it is an XOR of third and fourth bit. Okay, so third and fourth bit will be C and D. This is a logic circuit for binary to gray code converter. Now this is a gray code table. Okay, as we look at the diagram, every successive gray code will differs by only one bit. Okay, so every successive code will differ by one bit. So here only one bit. Here we have a change. Then here 0 and 1, and next bit we have 1 and 0. So exactly differs by only one bit. That is a gray code table. Okay. And next one we will see the vice versa. That is a gray to binary code conversion. For the gray to binary code conversion, again, the most significant bit of the gray code is equal in binary number. Now move to the next gray bit. As it is 1 of the previous bit will be alter, that is it will be 1, thus the second binary bit will be 1. Next to see the third bit. In this example, the third bit is 1 again, the third binary bit will be the alter of second binary bit, and the third binary bit will be 0. Okay. So now this is an example, 01101. This is a gray code. Okay, what is that is, this is a gray code. So now we are going to convert this gray code into binary. How to convert is, so 01101, this is a LSB, least significant bit, and this is a MSB, that is the most significant bit. So MSB we have to keep it same, 0. Then next will be, this is our gray code. We are going to convert into binary. So when we are doing convert into binary, what we are going to do is, first one, keep the MSB as it is. For next bit, we have to take the XOR of the result of first binary bit and XOR of next gray bit. Okay, 0 XOR 1. So this 0 XOR 1. What is 0 XOR 1 is 1. So that we have to write here. Then this result XOR of next gray bit. So 1 XOR 1, that is a 0. Again next bit 0 XOR 0, that will be 0. So 0 XOR 0 is 0. That is these two bits we have to do, 0 XOR 0, and this is a result of this one. Next one is 0 XOR 1, and 0 XOR 1 is 1. Okay, this is a gray to binary conversion. Okay, so I repeat again. So what is our original gray code is 01101. So 0 MSB key parasities retain the MSB bit. So 0, and next bit we got to 0 XOR 1. So 0 XOR 1, that will be 1. Then again 1 XOR 1. 1 XOR 1. So 1 XOR 1 is 0, and 0 XOR 0 is 0, and 0 XOR 1 is 1. So what are the merits and demerits of gray code? So gray code, it is best for error minimization in conversion of analog to digital signals. It is best for minimizing a logic circuit and decreases the Hamming walls, which is undesirable state when used in genetic algorithms. It is useful in clock domain crossing. The drawbacks of gray code, it is not suitable for arithmetic operations and it has a limited use. We will see one example for one more example. So assume that I'm going to convert this 1, 1, 0, 1, 0. This is a binary. Okay, this is actually in binary. I'm going to convert into gray code. This is in binary. I'm going to convert into gray code. Assume that 1, 1, 0, 1, 0, 1. Okay, first one, this MSB, I have to retain as it is 1. Then 1 XOR 1. What is 1 XOR 1 is 0. Then 1 XOR 0, it is 1. 0 XOR 1, 1. Then 1 XOR 0, 1. Then 0 XOR 1 is 1. Okay, this is a equivalent gray code. This is a equivalent gray code. Now we are going to convert again into binary. How to convert into binary is again keep the same 1, then 1 XOR 1. So take the 1 XOR 1, it is 1. Then again 1 XOR 1, it is 0. Then 0 XOR 1, it is 1. Okay, 1 XOR 1 is 1. 0 XOR 1 is 1. Then 1 XOR 1, 0. Then 0 XOR 1, 1. So we got the result. Thank you.